All right, let's take a look at this. So let's talk real life. So in real life, when a basketball is thrown, it has a parabolic shape, right? Parabolic shape. Given by this equation right here. Only it's not in the form that we have been using, right? This 14.56 should be over here with the y. So it should be y minus 14.56, correct? And then the x is going to be on this side, x minus 10.98 squared. They're ugly numbers. Just pretend that's a 1 and that's a 2. It's okay. We'll be fine. And this is negative 0.07 in front of here. If I were to get it on this side, I'd have to divide both sides by it. So this is my LLR. Which is actually a big number. So it looks really crazy, okay? But it's really not that crazy. And what the sense I can make out of it is this is my vertical shift, correct? So I would go over positive 10.98, which is right about here. And then I would go up 14.56, and that would bring me to my vertex, or maximum height. Correct? I can get all of that from this equation right here, or the one in white. It's just changed a little bit. It's not in transformational form. It's in vertex form. So I can also get another piece of information from this. See over here where the basket is? That's at 19, 10. Let's get a fresh screen here. So could you come up with the equation of a line that intersects the parabola at the basket? So basically, these are two different systems that are going on here. One is a parabola, a parabolic path of that ball going in, and one is how can I figure out exactly where that is going to intersect at the basket. Two different equations. One is a line, and one is a parabola. Okay? Now, believe it or not, you guys could easily come up with the equation of this line. Can anybody give me the standard form of an equation of a line? It was ingrained in you since 7th grade. Y equals mx plus b. Do you know the b? Where it starts. Where does it start? 0. So do I need to include the 0? Now I just need the slope. You actually have the slope right in front of you. You don't need the graph. Is it 1910? What does 19 stand for? What does 10 stand for? I rise 10 and I run 19. Right? Isn't all those pieces right there for you? How do I know? Because I run 19 and I rise 10 to get to that point right there. Because slope is actually your change in y over your change in x. So I went up 10 and I went over 19. That's the equation of that line. So what we're going to do today is we're going to pretend like we don't have this answer right here. We don't have this answer. All we have is this and this. And we're going to have to come up with that answer. Yeah, you're going to have an equation of a line, an equation of a parabola, and you're going to have to find where they intersect. Okay? So that's what we're going to be doing. But not crazy numbers like this. more simple numbers and things that you can graph. So we're not just going to find it algebraically with systems of equations, but we're going to find it graphically because you've been graphing conics for weeks, right? So you should be able to graph it and check your work on the algebra piece. Doable? But you see how you've done both, but now we're going to do them together. All right. So students will apply their knowledge of graphing conics to check their solutions of systems of equations. Do you guys remember systems of equations?
Oh, yeah.
Okay, discuss with your table partners how you could eliminate to solve that system. Kayla, what did your table come up with? Kayla, what did your table come up with? You weren't really sure. Can you look? I'm not going to let you off the hook. When you go and you look through this, there's got to be a strategy to eliminate. There she is. All right, sounds good. Good to see you. That's her. Okay. Nope, I'm not letting Kayla off the hook. What do you see up there that these two have in common? The coefficient of the y. So if I add them together, what would I get? Hold on. 6y. So what do you think I should change before I try and add them together? I'm trying to eliminate one of them. Eliminate. I don't have enough hands. You guys, this is since what? We started this in 7th grade, I believe. Okay, but you've done it every year. Kayla, I'm not letting you off the hook. We're trying to eliminate. Do what? Okay, Sarah? Multiply the second equation by -1, or I would say subtract them. So if I were to subtract, then -4 would now be +4. Let's change my color. Well, it's the same thing as multiplying by -1. If I were to subtract 3y, it would now be That's why I said remember. Do you remember? Okay. Kayla, is this coming back now? And subtract that? So now what happens? It eliminates the 3y and the -3y. And 10x and 4x make 14x. I'm going to change this to 20 and a 6. Sorry. 20 and a 2 and a 6 and a 2. You guys get that? What I just did? I broke them both up because this gets eliminated, and I can pretty much see 20 minus 6 is 14. It's the little thing I do in my head. Or you could just take 22 and subtract 8, right? I'm trying to get you to be able to do things like this, though, making sense of numbers. That's number sense. Number sense. 14x's is 14, so 1x is 1. What am I going to do with that 1? Sarah? Well, but let's wait for the question until we finish this. Kayla? Okay, we're going to substitute it back in. Which one would you like to do it with? The top one or the bottom one? The bottom has smaller numbers. It has a positive, a negative, and a negative right now. 4 times 1 minus 3 y's equals -8. This becomes 4, and we subtract 4 from both sides. I get negative 3y equals negative 12. So y equals 4. What did I just find?
You're right.
What does this represent? What is that? Is that a parabola?
It's a line.
It's a line.
Oh, it gives you a line?
You're right.
And this is a line, because neither one of them are squared. Do you guys get it? When neither are squared, it's a straight line. When one of them gets squared, it starts to curve. When both of them are squared, it makes a complete circle or ellipse. And when they're both squared and they're minus, they're going away from each other. Right? See how it all comes together? Okay. So if they're both lines, what would I call what I just found?
You're where they touch.
You're where they touch. Your intersection. I just found an intersection. Right? It's a solution. So you could say if one cell phone plan is this one, and one cell phone plan is this one, this would be where they're both equal. They're both at the same spot. Right? Right? Remember we talked about, like, if you had two, guys, I need your attention. Remember we talked about if you bought so many tickets to go to a game, and then if you got the package where you got the jersey first, and it was, right, and there were two different ones, but one was more expensive than the other in the beginning, and in the end, the other one, it kind of switched. And where we found their intersection was where it didn't matter, like if you went to 3 games, it wouldn't matter which one you chose, right? So that's what that is. So we're going to talk about, I want to see if you guys can, in groups, tell me, not solve it all the way through, but tell me how would you eliminate something there. All right, guys, number 2. How about, Lucas, what did your table group come up with? How would you eliminate for this one? What would you do in order to eliminate this one? One of them. Yes. Change it to what? What did your table group come up with? What strategy would you come up with to eliminate either the x's or the y's? Divide by -1. Okay. So if I divided this whole thing by -1, this would be positive, this would be negative, and this would be positive. What else would you have to do? I can't get rid of this, and I can't get rid of this yet, because this is 14x if I add them, and this, if I add them, is 6y. So what do I need to do? Kayla. Multiply the bottom one by not just a -1, but -2. So now it's positive 8x, -12, and positive 60. So now when I add them up, that's going to go away. I'm eliminating one variable, and now I'm only dealing with one variable. Another one? We still haven't Algebra 2 up yet. Okay, we're still in Algebra 1. Okay, talk with your table partners. What would you do for this one? 1. Carrie, your table. What strategy did you guys come up with? Carrie, what strategy did your table group come up with? Multiply the top by 5 and the bottom by 2. That would make this 10y, and that would make this -10y, and then they would go away. Did anybody else come up? Good job. Would anybody else come up with a different strategy? There's another one. How could you get rid of the x? Now we're thinking like Algebra 2 students. Multiply the top by 4 and multiply the bottom by 5. Sorry. By 5 and the bottom by... Okay, Algebra 1 students would multiply this by 8 or negative 8 and this by 10. But they have a common factor of 40. So I could turn the 8 into 40 by multiplying by 5 and the 10 into 40 by multiplying by negative 40 and then eliminate. Last one? You think you need one more?
Well, we don't need it.
Okay. I don't think we need it either. I'm going to skip over this one. This one's your first one on your homework. What are these? They're lines. They're both lines. So I'm going to graph them. This is all I'm going to do on this one. I'm not going to solve it because you should be able to solve it. But before I graph them, what do I need to turn them into? Okay, so I'm going to do the first one. Right? You're going to turn them into y equals mx plus b. All right, let's do the first one. So the first one, I'm going to need to get that x on the other side. So negative 5y equals negative 10x plus 10. Then divide everybody by negative 5, negative 5, negative 5. And I have to end up with y equals 2x minus 2. I'm going to graph that. Go down 2. Up 2 over 1, up 2 over 1, up 2 over 1. I can make that into a line really quick. Second one, same strategy. I'm going to make them both into lines and graph them. Because originally, first I'm going to do the algebra, and then I'm going to graph it and check to see if my algebra was correct. Because see if they intersect at negative 2, negative 6. So let me change my color. I'm going to move that 20x, so it's going to be negative 8y equals negative 20x plus 8. Did I do something wrong? So I'm going to divide everybody by negative 8, which looks messy, but it's not really that bad. I shouldn't hear any talking. I should be like to hear a pin drop. Okay, so these are both going to become positive, and I can factor out both a 4. So this becomes 5 over 2x minus 1. So I go down 1, and I'm going to go up 5 over 2. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. I don't think it's ever going to go and intersect there. It's probably going to intersect down here. So down 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. Now the lines are not perfect, so I should probably just keep going with the dots, right, until I find an intersection. So if I was going up 2 over 1, I'm going to go down 2 over 1. Down 2, bingo, right there. Right? Counting the slope is much better than trying to match it with lines, because your lines aren't going to be perfect, but counting the slope is going to be perfect. So if I were to do my green, see how my line wasn't perfect? But my point is perfect. Let's double check. It said negative 2, negative 6. Negative 2, 1, 2, 3, 4, 5, 6. It would be considered a no solution, right? If they don't touch, it'd be no solution. And we're actually going to see something like that in a second. Okay, so everybody understands? You're going to do the Algebra 1 part on your homework, which is solving for the system of equations, and then you're going to graph it and make sure you're right and I graphed it for you. Now let's algebra 2 it up. Okay. So, you could easily graph those two. Tell me what they are. One's a circle. No, the hyperbola. Okay? So these could intersect in a couple different ways, right? I could have a hyperbola with a circle. There's 4 intersections. I could have a hyperbola with a circle over on here, and there's 2 intersections. I could have a hyperbola like this, and the circle just touches it. There's one solution. Or what about this one? No solution. Right? So we're going to be able to find all of that with algebra now. How are we doing on time? Okay, we're doing awesome compared to my other class. Okay. So, we need a strategy. I don't want to work with this. Can I eliminate anything right now with it looking like that? So what have I taught you about fractions? Multiply it by a common denominator. What would be the common denominator of the 9 and the 4? This is actually working backwards from what we had before. If I were to find this, it could originally have been this. 4x squared minus 9y squared equals 36. And what do? You divide everybody by 36, right? And I would get this, because these would cancel and it would be a 9. These would cancel and it would be a 4. So I'm going to work backwards. I'm going to say I'm going to put it back to where it was before. I'm going to multiply the whole thing by 36. Let's go with green. So if I multiply all of this by 36, I'm going to get, okay, imagine it. 36 is being multiplied by this. What's going to be left over after the 9's crossed out? And 36 is multiplied by this. What's going to be left when the 4 is crossed out? Minus 9y squared equals 36. There's 1. What am I going to do to this one so I can eliminate? Negative 4. Because if I multiply it by negative 4, I'm going to get negative 4x squared, negative 4y squared, and negative 36. Now it's not so bad. Right? Cancel. These cancel out. And actually these cancel out too. And I'm left with negative 9 and negative 4 is negative 13y squared equals 0. So what does y equal? Y equals 0. Now I've got to find x. All I got to do is plug it back. I'm not going to plug it in there. That's crazy. That one looks easier. Right? You could put it in there and you're going to get the same answer. Okay, so I'm going to put y back in here. So I've got x squared, x squared plus y squared equals 9, and y is 0. So this ends up being x squared equals 9. So x equals not just 3, positive and negative 3. Because if I put a negative 3 in there and squared it, wouldn't it be 9? Right? So it's both of them. So my solution is actually 2 different points. Right? X can be 3. This is my x and my y. This is my x and my y. So x can be 3, and x could be negative 3. So what's y when x is 3? And what's y when x is negative 3? still 0. Let's make sense of that graphically, which is really easy. Really easy. Check this out. The first one you guys said was a circle, right? The center is at 0, 0. If I were to divide both of them by 9, then my r squareds would be 3 squared and 3 squared, right? So we're going to go out 1, 2, 3, 3, 3, 3. There's my circle. This is a hyperbola with the center at, again, 0, 0. It goes out on the x, 3, and it goes out on the y, 2, right, because they're actually squared. So my 3, bingo, there's one intersection, -3, there's another one. Up 2 would be here and here. I'm going to do a really faint slope box. Really faint on my asymptotes. They're just guides, right? That's all that is. And is this going to be a vertical hyperbola or a horizontal? Vertical, because x comes first. No, no, no. That would make it horizontal, right? Because it's on the x. So we'll actually do that in red. I just did that backwards. And there's my intersections right there. Isn't that what we found with the algebra? 3, 0 and -3, 0. So this is going to be the work tonight. That's going to be the work. But luckily, you have this as a backup to see if you're right and whether you're wrong. No, I haven't graphed it. You guys can graph that fast, right? Okay, let's do the hardest one on the worksheet. So right now on the worksheet, there's only problem 1, 2, and 3. I already did number 2. Number 1 is an Algebra 1 problem. So you guys basically just need to do number 3, right, and copy my stuff. I'm going to do number 7 so you can just see the complexity that it can get to. And then I'm going to give you your homework. Okay? Ready? You want to try it? Give yourself, see how far you can get. How'd it go with Cassandra? Cool. She did, just for a moment, it was a hard day today, so it's a good thing that she's like, I know how precious your time is today, but I'll be here next week. I am. Does anybody think they can figure out what they could eliminate? Yeah. It's just more complicated. Amanda? I want you to struggle with it a little bit first. Okay, what you lost something here.
What, this?
Oh yeah, this and this is not that.
Was it cute?
No. But you're on the right track. Okay, 5, 4, 3, 2, 1. Okay, so I didn't pause my video, so now it's going to be really long. Hopefully somebody's just like fast forwarding through it. Okay. We ready? Okay, I'm not going to do anything to the first one, but I recognize the fact that I'd love to get rid of this. Right? So in order to get rid of it, I'm going to have to bring the x squared on this side But at the same time, I might as well distribute. Right? So I'm going to do that right now.
Yeah, are you going to switch the X and the Y?
I'm not going to switch the X and the Y. Check this out. Okay, so let's do this first. I want to put the X squared on this side, so it's going to be negative X squared. I'm going to distribute positive 8Y minus 40 equals 0. Now I want to make this one look a little bit more like this one, so I'm going to go ahead and rewrite right now. This one's just going to stay like this, X squared plus Y squared equals 25. This one is going to be negative X squared plus 8Y. And I might as well put that constant on the other side. All right, now here's where you guys meet. There's a common misconception here. This is going to go away. But now I'm left with Y squared plus 8Y equals 65. 8 Y's and Y squared is not 9 Y's. And it's not 9 Y squared, right? This is Y squared. It's like saying there's bunnies, there's a bunny, and then there's a rabbit. 8 rabbits and a bunny. You know what I mean? Like, you can't combine those two. They're two different things. Y squared is different than, one of them is a line, right? And one of them is a square. You can't do that. So, did you guys see something that you could do? Kayla? No, because you've now solved for Y for this one. Okay, so you're saying that Y is, on this one you're saying Y is plus or minus 5. I like that you're seeing stuff like that. And because if I were to square root both sides, it would be a 5 and a negative 5. And then I would have to put the 5 in there, and I would get 40. That would equal, do you see how that's not working? So there's another strategy here. Amanda, I could complete the square. I'm so impressed that you guys saw that, because you know what you know what my mind does, because I've been programmed Algebra 1, procedure. Both me and Miss Wiz would have done this. The other way is easier.
Yeah, definitely.
The completing the square is much easier. So look at, if I complete the square for this one, isn't it just Y plus, what's this going to be to complete the square? 4, and what am I going to have to add to the other side? Which becomes 81, which is a nice square. That's not okay, is that what you just said? Right? Doesn't that work well? Now, I do what? Take a square root of both sides. Do you see what I meant by it's not hard?
No, now it's not.
Carrie, we need to change you to the other seat so you can be looking at the board. So now it's just Y plus 4 equals plus or minus 9, right? And then you take the 4 and subtract it, and it's negative 4 plus or minus 9. So Y is either negative 4 plus 9, which is 5, or Y is negative 4 minus 9, which is negative 13. Now we found Y. We're going to use both. So, I shouldn't hear anybody talking right now. You should all just be like, holy cow. Right? Let's start with the 5. Let's plug 5 back into the first one or the second one? Okay. I like the second one better, but all right. So if I put 8 in here, 8y minus, sorry, we're putting y in, y minus 5 equals x squared. If I put a 5 in there, I get 0, and 0 times 8 is 0. So x squared is 0, so x is 0. What if I put the negative 13 in there? Let's try that one. So the first solution is going to be 0, 5. And the second solution is going to be 8 times negative 13. Negative 13 minus 5 equals x squared. All right, we can work with that. What's negative 13 and negative 5? Negative 18. What's negative 18 times 8? 144. Negative 144. Negative 144 equals x squared. What do you see? I. What does I mean? It's imaginary. What do imaginary mean? What does that mean when it's imaginary? Complex roots, which means there's no solution.
That's annoying. Oh my god, if that was a test and I did that, I would be so mad. I would
Okay.
stop doing the test.
So there's only one intersection point. The other one, it doesn't. It's there, but they're not intersecting, right? So let's graph it and make sure. So here was our original solution, 0, 5. So I'm going to graph the first one, which is super, super easy. We've got a center at 0, 0, and a radius of 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's my circle. This is a it's a parabola. Only one of them is squared, and its center is at 0 and 5. There's our intersection right there. It's 8 wide. If it's 8 wide, what's P? So I go up 2. That's my focus, and out 1, 2, 3, 4. 1, 2, 3, 4. There's my parabola. I only have one intersection. It's not complicated. It's just a lot. Okay?
That was the hardest one. So
We're not doing it just by graphing because we already know how to graph. We're going to do it both ways. And Miss Wiz and I would argue that this is the Algebra 2 part right here. And actually in the standards right now, they used to be this, actually 2 and 3 variable systems. But they wouldn't graph them together. They would usually only do them just all the algebra. So now we're pulling them both together so you can see what you're doing. And actually this is more Algebra 1, but we feel like you really need help with this piece, the straight algebra stuff. So we're going to have you do them side by side. So your homework tonight is to finish the conics. If you're finished the conics, finish your, you've got the take-home test, right? Your cumulative take-home test. And then do the front side. If you really want to, you could try the back side. I've already done one of them for you. Yeah, this one's on the back. There's only 3 on the front and 4 on the back. This is the last one, number 7. Let's go to our... So what are we finding when we find the solution to a system of equations? An intersection. Good. How do we determine what to eliminate? Whatever you want, whatever makes sense to you, right? If you see 2x squared, you're going to somehow eliminate those. If you see a y and a 2y, you could just multiply the one of them by 2, right? So you're doing whatever makes sense to you. Is elimination the only way to go? Do you guys remember another method? Substitution. All right, that's what I was going to head to tomorrow. Okay? So I'm going to pass out your homework and let you guys copy down which one, number 2? And then you've got number 7 online if you want it. Let's look at number 3. What would we eliminate on number 3? Right there. Right? Okay. So I'm going to put this one up here. I'm going to go ahead and stop my video. Bye, video. Yes, please.